All right, Bismillahirrahmanirrahim. Let's go to a new topic, and certainly the last topic of chapter 9. In this topic, inshallah, we will cover and we will try to learn how to locate the centroid of the composite areas. But the area, by meaning composite area, as the name suggests, tells you it will be two-dimensional areas. Okay, and by composite means that these 2D areas will be made up together of different composite segments, like you can have a rectangle, a square, a triangle, a semicircle, or basically a circle in the form of a hole in the segment. Okay, so if you look at this, it's a very complex kind of a shape, uh, which is basically made up of various geometrical areas. Like if you look at this shape over here, uh, if you look at this shape over here, let's open the laser, and if you look at it, this shape, okay, we can see that this shape is basically being made up of various segments. Here if you look at it, one, if we can make this as one segment, this is a rectangle, this is a square, number 3 is basically, and you look at this picture also, this is a triangle, and if you look at this is a semicircle. Okay, now when you say that, sir, 1, 2, 3 are basically, you can see as shaded area, shaded composite areas, but 4 is written here, but it is not a shaded area. It is not a shaded area. Yes, we will try to basically because this is not there, we will try to assume that this shape or this semicircle is basically being added up, and added up to form a rectangle. It is being added up to form a rectangle, and since it is not there, so we will perform a Boolean operation, and we will try to first of all assume it is there, and then we will subtract it, the same semicircle from there. So we will say that it is actually it was not there. So when we try to calculate the area of this quarter of a circle, we will do it by as the conventional formula of the area of a quarter circle is pi r square by 4. But since this shape is not there, so along with this area we will always write a minus sign, because it is in practically it doesn't exist. So we will write a minus sign with this semicircle. So very important thing. Apart from this, you must be able to understand uh, the formulations which are very important here. And if you look at it, for triangle, you will say the centroid of the triangle will always exist at x bar y bar equals to h by 3. Okay, so it will be somewhere this centroid will be, you can always assume, let's say for us it will always be centroid will be somewhere, if you look at it, it will be here. This centroid will be somewhere here of this triangle, and you can easily say the centroid of this, just by observation, you are not basically being uh, somewhere of this square will be approximately here, and this will be somewhere, because this is 6, so and this is basically 7, so some 3.5 and somewhere 3, somewhere approximately you can say it is here. Okay, but so we will say that the triangle centroid will always be at h by 3. Okay, h by 3, and basically they are trying to say that, for example, from the like if they, as I have told you, if this is a triangle, so from this side A, if I say this is the centroid, okay, this is the centroid, so from here to here the length will be, if the total length is say x, so it will be 2 by 3 times of x. What will be the remaining side? It will be x by 3. Remember this thing, very important. I have explained to you. So the same logic he is trying to tell you over here is that is basically for a triangle. Basically, the centroid x bar y bar will be equals to h by 3. Okay, and uh, basically if we are taking it along the, for example, if we are taking it from the x, it will be 2h by 3, and along the y you can say it will be h by 3, because the thicker side will be the more area will be coming. So 2 by 3h, the thin side will be h by 3, and from here the thin side will be h by 3. This you can say this is x by 3, and this will be 2x by 3, you can say. And the other thing for that, you can say it as in the y, when we go, we will say it is h by 3. Okay, so the area of the rectangle will be half into base into height. uh, what about the circle? The circle area will be, since it is a quarter circle, it is going to be pi r square upon 4, and for a quarter circle you must always remember the centroid of this quarter circle. The centroid of this quarter circle will be at, if you look at it from the x bar, it will be 4r upon 3y, and from the y bar it will be somewhere here 4r, if you see somewhere here 4r upon 3 pi. So 4 radius is given as 3 inch, so 4r 4 into 3 upon 3 pi. This will be the centroid of the quarter circle. The rectangle area is length into breadth, and its centroid will be where the medians, where the diagonals meet, are length of the half and breadth of the half. Very simple. So for this we have to construct you must remember that the formula for, since it is an area is involved, and so because of the involvement of the area, uh, you must remember that x bar, since we have to and remember that we have to calculate centroid. Centroid means x. Centroid means what it means, not only x bar, but you must always remember it also means that you, after calculating x bar, you must calculate uh, y bar. You must calculate y bar. So this is very important. Basically, not only x bar is to be calculated, but you also have to calculate your respective y bar. Remember this thing. So first we will basically try to construct the table. This table is very important, as it will basically help you in reducing getting confused, or basically step by step if you do it, it is going to be a very easy problem and make your problem very easy. If you do not construct the table, it will create a lot of difficulties for you in this solution. Okay, so how we will, if you look at the over here in the problem, main formula is, since it is composite, so you can no integral, but a summation sign is there, x tilde into a over summation of a. So for all the segments you have to calculate, for 1, 2, 3, 4 you have to calculate x tilde and their area. So let us stay in segment 1. Where is segment 1? This is 1. So this is the segment 1. This is the segment 1 shown to you over here. So for this segment 1, we will assume that basically the length is basically 4 plus 3, 6 inch, and the height is 3 plus basically height is 3 plus 3, so it means 7. It means 7 into 6. You may remember this is 7 into 6. 4 plus 3 7, 3 plus 3 is 6 inch. Okay, so this to this is the height. So but remember one thing, as I told you, we are basically itself assuming that this rectangle is solid over here, and it is made up of 4 plus 3, 7 inch in length, and 3 plus 3, which means 6 inch of the height. But they remember it doesn't exist here. Okay, after just to ease our calculation, we are saying that this rectangle is of 7 into 6 is 42 inch, and we will remember this x tilde will always be calculated from the, as I told you in the previous numerical also, from the origin. So its x tilde will be centroid will be somewhere here, but from the origin it will be 3 inches plus 7 inches half. So 3 plus 7, 4 plus 3, 7 divided by 2. So it will be 7 by 2 plus 3 equals 6.5 inches. And you calculate your x tilde. This x tilde multiplied by area, 6.5 into 42 gives you 273. All right. So now we go to segment 2. If you look at this segment 2, this is my segment 2, this is my segment 2 is my square. From the area, what is the area of the square? It will be length into length. So what is this length? 3 inches, height 3 inches, 9. And from the origin, what will be the centroid along the x-axis? It will be, so x tilde will be 3 divided by 2, 1.5 inch. X tilde into a will be what? It will be 9 into 1.5 is 13.5. Now you go to segment 3. Segment 3 of the area is 3 is triangle. Triangle area will be half. What is this? This is base 3 inches and height is also 3 inches if you look at it. Okay, but now the main thing, it's x tilde. It's x tilde from the origin. If I say this is the origin along the x-axis, this was the origin, we can assume also this is the origin. So if we move to this point, somewhere here, if it is our, I told you like here, our centroid is of the triangle is here. So basically, this is the thicker side. This is the thicker side. So it will be 2x by 3. So the total length is 3. So we will write for the triangle 2 by 3 multiplied by the total length along the x is 3. So this is 2 by 3 of x. So 2 by 3 times multiply by 3 because the total length is 3. So 2 by 3 multiply by 3. So multiply these two, you got 9. And number 4, if you go, what is the fourth side? The fourth side is basically this quarter circle. And what is the area of this quarter circle? Pi r square by 4. What is the radius? Pi and radius is going to be 3 inches. So you can write pi into 3 square oblique 4 is 7.068. But see, this we made this when we calculating the number 1 rectangle, we make this as a solid, but actually it doesn't exist. So when we calculate this quarter circle, we calculate it normal way, but here we have put what sign? Minus, because it never existed. It was never physical. It was always virtual. So we write minus sign. And for to calculating the centroid of this quarter circle, again remember the very important point, from the origin we have to move along x. From the origin we have to move along x. So if we move from the origin, it will be 3. Okay, so if I say this is from here, we can move like 3 inches plus 4 inches, 7, and we can also move to here is again 3 is 10 inches, 3 plus 4, so we are here right now. But what is the centroid of the quarter circle? 4r upon 3 pi. 4, what is the radius? 3 inch upon 3 pi will give us a value of 1.273. So, but this is basically 1.273 is basically moving along x is something like this. From here we move this word, but we want our centroid from this origin. So that is why I calculated till 10, and then we minus this value which is 1.273. So we will get this value 8.727, which will be starting from here. Yeah, you can say from here to somewhere here. This value will be of this centroid along the x is somewhere like his 8.72, which like from here to here. Remember this thing, it is 8.727. And again you multiply, very important point here, very important point. If you multiply 8.727 with 7.7068, you will get 61.628. But remember one thing very important, remember when you are multiplying the area, it was minus. So minus into the centroidal coordinates will give you minus 61.682. So you got this. Now what is going to be your next assignment? Because if you look at the formula, the formula says that you, for all x tilde into a, you will add it. So when you add all these x tilde into a, 1, 2, 3, you will add it, and this is the minus 1. So you will get a value of 233.818. and you add all those areas. You will add this area, you will add 9, you will add 4.5, but you will minus 7.068. So you will get an area of 48.432 inch square. And remember, this x tilde into a, area is inch square and x tilde is again a length dimension in inch. So inch square into inch will give you inch cube. So x, the centroidal coordinates will be 233.818 calculated from here, x tilde into a after summation it, and summation of all the areas is 48.432. So you will get the x bar coordinate of the this composite area is 4.827 inch. So if you look at it here, it will be 4.287 inch. Again, this will be from the origin. It will be from the origin. From here you will move like this is 3 inches, 4 inches somewhere here, you can say. And then you also have to go what is the y coordinate, y centroidal coordinate of this composite area. So for this you will basically go to the, let's go to the next slide, and this is my next slide. I will be really quick in this because I have already explained the fundamentals to you. You again basically what you will do is that you will calculate the area previously calculated, 42 inches which is from the origin, basically from your origin. If you look, this is 7 into 6, 7 into 6, 42. But along the y, now this y tilde basically from the origin you have to go, what will be the centroid from here, from this point, because this total in y along the y length is 6. So centroidal coordinate will be 6 half, which will be 3. You multiply y tilde into a, what will be go for the square, it will be 3 into 3 is again 9 inches, but this square centroid along the y axis will be, this is 3. So 3 half of 3 is 1.5. Multiply both of y tilde into a. What about the third one? This is the tricky one, the triangle one. Again the area of the triangle is the same, half into base into height 4.5. But what will be the y tilde? If you look at the y tilde, it will be basically from here I will move, because from the origin again I will move to 3 inches, plus I in the previous slide the centroid was just at this point. If you look at it, it was, remember it was at this, which point it was, somewhere at I told you it was this point. So this area, if you look at it, is 2 by 3rd of the 3 inches. So this will be 1 by 3 of h. So it will be 1 by 3 of 3 plus 3. This was the 3, and this height, which is 3 inches. So 1 by 3 of 3. If you look, the area is little here, and the more area is over in this domain. Multiply them, you will get 18. And same logic if you go here for the 4. Basically again, because this quarter circle never existed, we calculated its area, pi r square 4, the radius is again 3 inches, you get minus 4, 7.068 previously. But again, this is a tricky point again, how you calculate the y bar of the quarter circle. So we will again be calculating how we will moving from the origin, 3 inches, we will be moving from the origin. Let's open my laser first. We will be moving from 3 inches, and again you will be moving 3 inches. You at this point, because the calculation are done from there, and pi r square by 4. That was the formula, pi r square by 4. So you will get it as you are here 6 inches minus the centroid, pi r square by 4. Centroid was pi r by 4, I think so. Yes. If I am not wrong, but let's check it. What was the centroid? Just wait. It was, yes, the centroidal coordinate, sorry, the centroidal coordinate 4r upon 3y. The centroidal coordinate was 4r upon 3y. So you calculate this value, 4r upon 3y. 4 into r is the radius is 3 upon 3 pi. So because you add 3 plus 3, you were actually here. You were actually here. And you want the coordinates from the origin. So from this was 6, and I minus this value 1.273. So I will be along the y-axis, I will be somewhere here, and along the y-axis I will be say somewhere here. Say I will be somewhere here, and the value from the origin will be 3. The 4.2727 inch will be 3 plus 4 1.7, it will be 4 point from here to here, it will be, for example, you can say it will be 4.727, whatever it is. But this is for the y tilde, and again you multiply negative area with the y tilde, you will be getting uh, this minus 33.410, and then again you will be using uh, the same formula, y bar equals to summation of y tilde into a or summation of a. So you have calculated all the y tildes into a, you will add it and you will get 124.09. You will add all the areas, the 1, 2, 3 positive areas, subtract this area, and you will get 48.432 inch, and you divide both these values, you will get the centroid as y bar equals to 2.563 inches. Okay, so this will be the centroid, 2.563 of an inch along the y bar. And if you look at it, what will be the centroid along the x bar? It was 4.827 inch. So if you look at it, 4 point and here and 2 point something, like it will be, the centroid will be somewhere, the centroid so will be somewhere, it will be somewhere here, if I am not wrong, approximately. Okay, so this is how you calculate the centroids of various segments of composite areas. Basically, it's a quite complex shape, and the most important thing, remember, you have to construct this table. This table is very important, pivotal to calculate accurately the centroid of the composite areas. In my previous videos of the centroid and center of gravity, I have also solved two simple shape composite areas numericals. If you look at it, you can basically further see those two simple problems, and then you can come to this complex problem. I hope with this we finish our chapter 9, and you will have better able to understand this chapter 9, centroid and center of gravity. And thank you very much. Inshallah, I will see you in my next class.